Hey there, everyone, in Econ 1A. Today, I wanted to go over everything we talked about in Chapter 3. We went through the Chapter 3 material a bit quickly. I know for some of you it's a review, and so it made sense and enhanced what you already know, or at least reminded you. But for some of you, you've never seen this material before, and we went through it a bit quickly. So I want to talk a little bit more about the production possibilities frontier, how we use it to look at trade, and where those gains from trade come from, and just sort of wrap it all up. And so to do that, I'll start with the same example we talked about in class, and then I'll look at some other examples because there are going to be some similar typed problems in the homework for this week. So remember, we started out with two countries, right? We had the US, who had 50,000 hours of labor, and they could make one computer in 100 hours. Or 1 ton of wheat in 10 hours. And that should be fairly familiar because we talked about that, right? That's what we did in Chapter 2 when we first looked at that production possibilities frontier model. Now we're going to talk about a second country. We're going to look at the example of Japan. Japan has the same input, labor, but they don't have as much labor as the US, and they have different technology. And when we look at technology, basically what we're saying is, how much can Japan produce? How much time does it take for them to produce? So we have Japan over here. They have 30,000 hours of labor. And to produce one computer, they need 125 hours of labor. And to produce 1 ton of wheat, they need 25 hours of labor. Right? And then we can go ahead and graph the production possibilities frontiers for both countries, and we'll make the assumptions, some assumptions about how they produce, and look at their production and consumption. And we first look at them without trade because that's our initial condition. That's where we're starting out with this idea that, hey, what if we all just stayed alone and didn't specialize and didn't trade? And then we'll add trade in afterwards to show those benefits. So with the US, if we're going to look at wheat and computers, we went through and looked at what they could produce. Let me kind of move that a little better. Yeah. So the US could spend all of their energy, all of their 50,000 hours producing 500 computers and 0 tons of wheat, or they could produce 0 computers and 5,000 tons of wheat, or they could provide or produce any other combination between the two. And in the examples in Chapter 2 and in Chapter 3, we go through and make a lot of points, right? We go through and look at, what if we used 40,000 hours to make computers, 400 computers, and then we only had 10,000 hours to make wheat. That would give us 1,000 bushels of wheat. We don't need to know every single point along the PPF. That's the point of the PPF. That's what's so great about it. Just by knowing how to graph it, that shows us what every possible point is. So what I'm going to do is just look at the 2 end points, all computers and no wheat, or all wheat and no computers, and then the midpoint. What if we split the labor up in half? And that's just a shortcut to get the same amount of information without having to do as many calculations. So if I split the labor and spend 25,000 hours of labor on making computers, 25,000 hours of labor divided by 100 hours per computer gives us 250 computers, right? We can do the same math and take the remaining 25,000 hours of labor, only now we want to make wheat, and it only takes 10 hours to make a ton of wheat. And so that means that we will get 2,500 tons of wheat. And I can put that right here. So far, so good? This is in the textbook, and this is in the slides, and there's other examples that we can go through, and we'll go through examples for the in the homework too, and I'll go over some of those in other videos. So if you're still feeling a little bit rusty and uncomfortable, it's going to get clearer the more we go over it. Okay? So now I want to graph my production possibilities frontier. So I could have either 5,000 tons of wheat, or 4,000, or 3,000, 2,000, or even 1,000. And the same for computers. I could have 1, 2, 3, 4, or 500 computers. Right? And since I found my 3 points, I can go ahead and place them on my graph to help me draw my graph. So I could have all wheat and no computers, all computers and no wheat, or any combination between the two. Now in our example, we assume that the US is going to split their labor and make half computers and half wheat. Right? That's that first example. So, and that's reasonable, right? There's no wrong or right answer to the question of how to divide up your resources to produce those two goods. That's a personal preference. So some countries might say computers are more valuable. Some countries might say wheat is more valuable. And that gets to that sort of normative type question of what the nature of the way we believe the world should be. The positive questions would ask questions about what the trade-offs are, right? How many computers do I give up to get a ton of wheat? How much wheat do I give up to get a computer? So let's say if it takes 100 hours to make a ton of wheat, to make a computer, and 10 hours to make a ton of wheat, every time I make a computer, I'm giving up 10 tons of wheat. That's a positive statement. A normative statement is computers are more important than wheat. That's a judgment call, right? Okay, so that's the US. We've done that before. We're comfortable with that. Now we want to talk about Japan. Japan only has 30,000 hours of labor, and it takes 125 hours to make a computer, 25 hours to make a ton of wheat. So we can go through that same process and say, okay, if we were Japan, and we wanted to break down their labor to see what they could produce in any given amount of time, we could say that they could produce, with all their 30,000 hours of labor, they could produce, if they wanted to produce just wheat or just computers, we could calculate that by saying, okay, well, 30,000 hours of labor divided by 25 hours per ton of wheat gives us a total of, a total of 1,200 tons of wheat and 0 computers. If we split and use 15,000 hours of labor to make wheat, that 15,000 hours of labor divided by the 25 hours it takes to make a ton of wheat would give us 600 tons of wheat. And then we'd have 15,000 hours of labor to make computers. 15,000 hours of labor divided by the 125 hours it takes to make a computer is going to give us 120 computers. Okay? And then finally, we could spend all 30,000 hours just making computers. We would make 0 wheat, and we would make 240 computers. And you could break this down other ways. You could look at 10,000 hours of labor just to make computers and see how much wheat you would have when you use the other 20,000 hours of labor to produce the rest. The only rules here are that you want to use every hour of labor, and you can only produce wheat and computers using these two costs. The great thing about economics is because of that marginal relationship, right, that making a decision on the margin, you could even say, well, I only want to spend 100 hours making a computer, and say you're only going to make 4/5 of a computer. right? Because you can't make a whole computer in 100 hours in Japan. We could break it down into fractions of a computer or fractions of a ton of wheat. That's not super logical, but you could think about maybe getting most of the way through the process or something like that. And that's part of what we talk about when we talk about economists making decisions on the margin. We could pick literally any point along those curves and say, well, we're only going to use, a small amount of time to make a fraction of a computer and the rest on wheat. And that would be an acceptable division of that labor. It's a little weird, but that's the way economists like to think. So now if we want to graph the production possibilities frontier for Japan, again, looking at computers and wheat. And we're going to have the same general relationship, right? So there's, say, 2,000 tons of wheat. There's 1,000. That might be 1,500 and 500. And these aren't going to be perfectly to scale. It's nice if they are, but because the numbers are so different, you don't have to worry about that too much. It's not going to be super important right now. So let's say that's 100 computers, that's 150, and that's 200. And you can scale this however you like. So now I can go ahead and use the points I found to draw the production possibilities frontier. So I want to be somewhere between producing all wheat at 1,200 tons of wheat, or all computers at, keep going there, 2,000 or 240 computers. And so that's going to be right about here. And any point in between is both possible and efficient. Anything below the ppf is inefficient. Anything beyond it, it's not physically possible to produce. We're going to assume that Japan is going to split up between producing computers and producing wheat. And so we'll get that point of 600 and 120. So far, so good? So that's where we would be without trade. And I'm going to clear that up to kind of just make room for everything else we're going to be talking about. So without trade, we have the US has both computers and wheat, and so does Japan. Without trade, the US is producing and consuming 1,500 tons of wheat and 150 computers, and Japan is doing 600 tons of wheat and 120 computers. Now let's add in trade. And some people ask how we pick the trade points we did. I think we talked about it a little bit in class. This is an example that's designed to prove a point. And the point is that by specializing in something that you have an advantage in producing, you're going to be more efficient than someone else. And that's why, if you remember, I started out the lecture saying why Lizzo shouldn't do her own taxes and why I shouldn't play the flute for her. Because she's specialized in something that she's excellent at, right? Singing, songwriting, music, playing the flute. So that means that it's to her advantage to focus on the thing that she can do more efficiently than the rest of us, right? And that's how we get more efficiency. She produces more. And so that's what we're seeing here is if we can figure out which countries are better at what, we can have them specialize at what they're best at, and they'll be able to produce more than someone else. So that's why we grow avocados in California and not in Alaska, right? We have a comparative advantage. We'll talk about what that means. But we have an advantage in terms of weather, in terms of our soil, that makes it easier and more efficient for us to produce more avocados at a lower cost than Alaska does. And that's what we're looking at here. So let's have, as we saw in the slides, we're going to have the US focus on producing more wheat than they normally would. And we're going to have Japan focus on producing all computers. And we could do a lot of different versions of this that would still show the effects. But what we're going to do is we're going to have Japan focus on producing all computers. And we could do a lot of different versions of this that would still show the effects. But what we're going to do is we're going to have Japan focus on producing all computers. And we could do a lot of different versions of this that would still show the effects. But what we're going to do is we're going to have Japan focus on producing all computers. And we could do a lot of different versions of this that would still show the effects. But what we're going to do is we're going to have Japan focus on producing all computers. And we could do a lot of different versions of this that would still show the effects. But what we're going to do is we're going to have Japan focus on producing all computers. And we could do a lot of different versions of this that would still show the effects. But what we're going to do is we're going to have Japan focus on producing all computers. And we could do a lot of different versions of this that would still show the effects. But what we're going to do is we're going to have Japan focus on producing all computers. And we co this is a nice way to have it end up really cleanly and consistently. So we're going to have the U.S. focus on producing 3,400 tons of wheat. I'll go ahead and write that number in. And that means that they're going to spend the rest of the labor that they have to produce 160 computers. That's a little bit wonky. My scaling's a little off there. Okay. So that's where they'll produce. That's not going to be very legible, is it? Let's try this. Okay. Japan is going to only produce computers. And part of that is the US has a lot more labor than Japan does, and so it makes sense for the US to still produce some of both. Then it more sense for that for the US than for Japan. And part of it is because, like I said in class, this makes the example really, really obvious, which is nice. So then we're going to have the trade component come in. So we're going to have, let's see here. There's a good color pen. We are going to have Japan produce all computers, right? They're going to produce 240 computers. And what they're going to do is they're going to export some of their computers. They're going to export 110 computers and import some of the US's wheat, 700 tons of wheat. Meanwhile, on the other side, the US is going to do the opposite. The US is going to export 700 wheat and import 110 computers. And part of what we're doing in this example is we're simplifying, right? We're making this really simple. And so we're only looking at these two countries. So whatever the US exports, Japan imports, and whatever Japan imports, the US exports. And so that means now with trade, we can look at a different distribution of the goods that we're talking about, those computers and that wheat, right? So, is this going to show up here? I'm going to kind of tilt this down so you can see more. So now with trade, the US and Japan, let's see, yeah, it'll work, are going to have the computers and wheat they produce and the computers and wheat they import, not the stuff they export. So the US produced 240 computers and imported produced 160 computers and imported 110 computers. So they're going to have 110 plus 160 equals 270. Make sense? For wheat, they're going to export 700 out of the 3,400 tons of wheat they created. So 3,400 minus 700 equals a total of 2,700 tons of wheat. So far, so good. Japan's in the same position. They didn't produce any wheat, but they'll import it, and then they're going to export some of their computers. So they produced 240 computers minus 110 gives us 130, and then they're going to import 0 plus 700 tons of wheat. Do you kind of see that? Hopefully. If not, we can graph it, right? So now we're going to see that Japan's consumption point, not their production, just their consumption, is going to be this 130 computers and 700 tons of wheat. So 700 tons of wheat. This is 5. This was 6. So this is going to be 700 and 130 computers. So that's their consumption point. There we go. That's the word mostly. Same thing for the US. They are going to now have a consumption point that is 270 computers and 2,700 tons of wheat. So 2,700 tons of wheat up here. And 270 computers up here. This is wrong. Huh. I don't want to go back and remake the whole movie. So I'm just going to go ahead and fix this right here. The US's consumption point without trade was not 150 computers and 15,000 computers, right? It was 250 computers and 2,500 tons of wheat. That was wrong this whole time. And that's the hardest thing about teaching to no students is there was no one to yell at me, hey, you're wrong, your math is wrong. That's right. Sorry about that. I know that was confusing. Okay. So now we see our initial consumption points without trade, our production points with trade, and our consumption points with trade. So what do we get? We get specialization, where each country does something that they're better at than the other in a greater quantity. We get trade, that exchange, the exporting and importing. And we get this impossible consumption point. These consumption points are beyond the PPF, beyond what these countries could have produced on their own, right? That's what I said. Anything beyond the PPF, it's impossible to produce. But by specializing, they can consume more than they could have ever produced on their own. There is no way to make 50,000 hours of labor, 100 hours per computer, and 10 hours per ton of wheat to get this consumption point. It's just not mathematically possible. We can only get it when the two countries specialize. And that's the gains for trade. That's why Mankiw says trade can make everyone better off. Where do these gains from trade come from? How is it possible that we can make more by specializing? To do that, we're going to talk about this idea of advantage, comparative and absolute advantage. This is in the book. This is in the slides. We didn't have time to get to it in class yet. We'll talk about it on Monday, and you can take a look at it now. But it helps to remember that economists look at costs two different ways. There's that explicit absolute cost, and then there's that opportunity cost, and that's the tricky part. To understand absolute advantage, you just need to know that it's the ability to produce a good using fewer inputs. And we can see that up here, right? The US can make a computer in 100 hours, and Japan, it costs them 125 hours. So who has the lowest cost in terms of producing computers? It costs Japan 125 hours, and it costs the US 100 hours. That means that the US uses less time to produce a computer. That's called absolute advantage. What about wheat? How long does it take Japan to produce a ton of wheat? 25 hours. What about the US? 10 hours. So the US also has a lower cost in terms of labor, in terms of the inputs we have to use to make it, of producing wheat. They also have the absolute advantage in producing wheat. They have better technology for some reason that makes it easier cheaper to produce wheat and computers in the US. So where do the gains from trade come from? This is where we have to get into opportunity cost. And so we want to think about the idea of what we give up to get a computer or a ton of wheat. We talked about this already when we talked about the slope of the PPF showing us the opportunity cost. It's the same thing. So if we want to see what the real cost of one computer is, we need to know the opportunity cost, how much wheat we give up. So remember, we said if we want to know the opportunity cost of a computer, we want to set it equal to the ratio of the costs. We want to see how many tons of wheat we could make in the 100 hours it takes to make a computer, knowing that it takes 10 hours to make a ton of wheat. And if you like math, then this is going to work really, really well for you if you understand things mathematically. If not, I have another example. We can talk about it a different way. So if the opportunity cost of one computer is equal to 100 hours per computer divided by 10 hours per wheat, that leaves us with 100 divided by 10 is 10. And one way to think of it is the units cancel out. So hours divided by hours cancel out, the computer parts cancel out, and we're left with 10 tons of wheat. So the opportunity cost of one computer is 10 tons of wheat. Another way to look at it is say, okay, well, it takes 10 hours to make a ton of wheat. 10 goes into 100, 10 times, and that's pretty straightforward. It gets a little more confusing when we have a little bit more complicated stuff. So the opportunity cost of a computer is 10 tons of wheat. What about the opportunity cost of 1 ton of wheat? Well, like I said, we could do it mathematically and say the opportunity cost of 1 ton of wheat is equal to 10 tons of wheat per hour, or 10 hours per ton of wheat, divided by 100 hours for a computer, gives us 1/10 of a computer. Does that make sense mathematically? If not, another way to think of it, and this is kind of what I showed y'all in class the other day, is to think about how much of a computer you could make in 10 hours. So if it takes 100 hours to make a computer, and we have only 10 hours to see how far we can get into that process, we won't make a whole computer. There's no way the opportunity cost of 1 ton of wheat that takes only 10 hours to make is going to be a whole computer. It has to be a fraction of a computer because you'll only get a fraction of the way through that 100-hour process. Does that kind of make sense? So we would only make 1/10 of a computer in the time it takes to make a ton of wheat. So the opportunity cost of 1 ton of wheat is 1/10 of a computer. You'll notice these are inverses of each other. That's the way it goes because it's based on the ratio of the costs associated with them. Let's try it one more time looking at Japan. If we want to look, if this is, there we go, this is the US. Now we want to look at Japan. Japan can make 1 computer. If we want to find the opportunity cost of 1 computer, they can make 1 computer in 125 hours. And that means that they're going to give up making 25-hour tons of wheat. So each time they give up another, each 25 hours that they spend working on that one computer, they're giving up another ton of wheat, another ton of wheat, another ton of wheat, another ton of wheat. So we can look at the ratio of the costs and say 125 divided by 25 is 5 tons of wheat. Or we can do my kind of graphic example, spatial example, where we say, okay, if we divide time into blocks and we say, okay, here's 25 hours, 25 hours, 25 hours, 25 hours, 25 hours. It takes 125 hours to make a computer. In that time, we could have made 1, 2, 3, 4, 5 tons of wheat. Does that kind of make sense? It seems like I'm cheating when you go from big to small. It's easier when you go from small to big. So let's try it the other way. So the opportunity cost of one computer in Japan is 5 tons of wheat. And we'll see the inverse is true also. So if we wanted to find the opportunity cost of 1 ton of wheat in Japan, it's going to be how much of a computer could we make in 25 hours? It takes 25 hours to make a ton of wheat. In that time, could we make a whole computer? No, it takes 125 hours. We only have 25. So how far into that computer making process? Let's say it takes those, right? 125 hours to make a computer. We only have 25 hours of that time that we're going to be spending making wheat. So how much of that total computer gets made? 1/5. And again, you can find it mathematically. It's the inverse of the opportunity cost of the other good. And so if we're looking at the opportunity cost of wheat, it's going to be equal to the cost of wheat divided by the cost of computers equals 1/5 of a computer. And that's the other important thing to remember when we're talking about opportunity costs. We're not talking about a cost in terms of dollars or in labor. We're talking about the good we gave up. So every time we make 1 ton of wheat in Japan, we give up 1/5 of a computer. The last part of this is now to see who has the comparative advantage. And comparative advantage is just producing at the lowest opportunity cost. So let's get another fun color here. We want to see who has the lowest opportunity cost, which is known as the comparative advantage. And so we want to see who gives up the least. So if the US makes a computer, they give up 10 tons of wheat every time they make a computer, right? That's their opportunity cost. Every time the US makes a ton of wheat, it's saying goodbye 1/10 of a computer. Or sorry, every time they make a computer, it's saying goodbye 1/10 of wheat, goodbye 1/10 of wheat, goodbye 1/10 of wheat. When Japan makes a computer, they give up 5 tons of wheat. So who gives up the least amount of wheat when they make a computer, the US or Japan? Who has the lowest opportunity cost? Who gives up the least when they make a computer? It's not the US. It's Japan. Japan has the lower opportunity cost. A computer costs Japan 5 tons of wheat. It costs the US 10 tons of wheat. That's why we had Japan specialize in computers. They have the comparative advantage. They can do it giving up the least amount of wheat. The US has the comparative advantage in wheat because 1 ton of wheat costs them 1/10 of a computer. It costs Japan 1/5 of a computer. So they have the comparative advantage in producing wheat. And that's where those gains from trade come from. So hopefully that makes sense. Hopefully that helps kind of wrap up that last chapter. Let me know what questions you have. Hit up the discussion threads, and I will see you all next time. Have a great day and a great weekend.